A lot to the organizers for asking me to discuss this really fantastic paper. This is working well. I found it extremely creative and very interesting. Killian did a great job presenting, but I'll just give you my brief summary. So as I see it, there's three main ingredients in the paper. First, they perform a text analysis of firm earnings calls to construct a data set on the perceived cost of capital. And they use that data set to show that the perceived cost of capital is in fact not an unbiased estimate of the true cost of capital. And they sort of take that as evidence of irrationalities or distortions in beliefs. I mean, they don't use those words, but that's basically what they're saying. Okay. Second, they show that, then he didn't really focus on this, but that the forecast errors at the firm level negatively correlate with firm investment, capital labor ratios, positively correlate with the return on invested capital, meaning that these perceptions have real effects on the capital allocation. Okay? And third, they use kind of a workhorse model of capital misallocation, a la Shea and Klenow, to find large aggregate or macroeconomic consequences of these irrational beliefs, and in particular that the excess dispersion in the perceived cost of capital could depress aggregate productivity by as much as 5%. Okay, so the plan for today is like kind of three segments of the discussion. First, since this is kind of primarily a finance crowd, I figured I'd give you guys like kind of a quick primer on the misallocation literature in case people aren't super familiar with it, and in particular the connection between information frictions, cost of capital, and misallocation. I'll use that to kind of place the paper in context, and like any discussant worth their salt, I'll plug my own work a little bit. Okay. Second, I want to think how robust is their conclusion of irrationality, and I'll try and convince you that it's actually very robust, but not 100% foolproof. Okay? And finally, I'll ask, are the aggregate effects really so large? I mean, a TFP loss of 5% is quite big. The answer is going to be no. I think the TFP losses are actually much smaller, but not negligible, and I'll give you two reasons why I think that. Okay? Good. So here's what I want to think about as like a first-generation model of information and misallocation, which is like a really simplified version of a paper I wrote with Hugo Hoppenheim and Venki Venkaswaraman. Okay, so the firm investment problem is very standard. The firm chooses capital to maximize expected profits, which is just expected revenue, which depends on capital with some curvature alpha and expected productivity, minus the cost of capital. In logs, which I'll use lowercase letters to denote throughout the discussion, productivity is normally distributed with some expectation, some variance sigma squared A. The optimality condition says that the log of capital should be set equal or proportional to expected productivity minus the log of the cost of capital. Okay? And really a big insight of the misallocation literature is that in the first best optimal allocation, the marginal product of capital should be equal across all the firms and all set equal to the cost of capital. Okay? But what you can see here is that in fact, with this uncertainty over productivity, there's deviations in the marginal product of capital, which are equal to the firm level forecast errors. So firms just don't know their productivity. They kind of make a mistake. They choose the wrong capital stock. That leads to forecast errors that lead to dispersion in the marginal product of capital. Aggregate total factor productivity, what I'll call A, relative to the first best, what I'll call A star, is just a decreasing function of the dispersion in the marginal product of capital. That's just equal to the dispersion in the forecast errors. And so what we have in this simple model is really a tight link between information, that's dispersion in forecast errors, misallocation, that's dispersion in the marginal product of capital, and sort of macro outcomes. Okay? Now, there's three aspects of the analysis I want you to keep in mind while I go through the next two slides. First, we really focused on uncertainty over productivity and demand. The cost of capital here is common, known, there's nothing interesting happening there. Okay? Second, we didn't have any direct data on firm expectations. We assume rational learning. We had kind of a complicated signaling process that's not super important for today. And we kind of use that along with a set of correlations between firm productivity, investment, and stock market returns to identify firm level information. I'm not going to go through that, but I can talk about that after for anybody who's interested. And the third point I want to make about this model is it's completely frictionless. So conditional on the information environment, there's nothing a social planner or a policymaker would want to do here. The equilibrium is like second best. Okay? And that kind of calls into question, is this really misallocation, like in a normative sense, or is this just Forecast errors we can't do anything about. Okay. Good. So I'm going to call this like a second generation model, and this is my paper with Lucas Schmidt, who's sitting over here, and David Zeke. And what we kind of did is extend the model I just showed you to allow for heterogeneity in the cost of capital. So this is the RIT. The optimality condition is almost the same as before, but of course I have an RIT instead of a common R. Okay? And now misallocation comes from two pieces. One is the forecast errors I showed you before, and the other is the variance in the firm level cost of capital, what I'll call sigma squared R. Okay? Again, so there's a couple key aspects of this model I want you to keep in mind. First, we have heterogeneous cost of capital, but it's known. Okay? In the paper, we relate the cost of capital to exposure to aggregate risk, and we show how you can measure that using expected stock market returns, based on your favorite asset pricing model. Okay? Again, this is a fully frictionless model. These costs of capital are just compensation for bearing aggregate risk. There's nothing a social planner or a policymaker would want to do to correct this. Okay, so in a normative sense, again, it's unclear whether there's any real misallocation here. Okay, so I'm asymptoting to Killian's paper. So here we are. Okay, so in Gormsen and Huber, what I'll call GH, they allow for heterogeneous cost of capital, and it's also unknown. Okay, so here I've said instead of RIT, we have RIT perceived. The optimality condition is the same. They kind of abstract from uncertainty over productivity, so the A is known. The RIT is now what's not known. Okay. Misallocation comes from dispersion in this perceived cost of capital, but they kind of go one step further, okay, and they separate this perceived cost of capital into a rational component and an irrational component. The TFP loss, again, depends on the dispersion in the marginal product of capital, which is just the variance of the perceived cost of capital, and we can break that down into the variance of the rational part, the variance of the irrational part, and the covariance of the two. Okay? So what do I see as kind of the main contribution relative to the papers I showed you before? Well, like the paper with Lucas and David, they have heterogeneity in the cost of capital, but they add this wedge between perceptions and reality, which we didn't have. Okay? They distinguish between inefficient and efficient dispersion, okay? And they directly measure the irrational piece of the perceived cost of capital via this regression of the forecast error on the perceptions. Okay? And for the next two slides, I'm going to talk about that measurement approach. This regression of forecast error on perceptions is that evidence of irrationality. Good. So, as the paper is very well aware, but I just want to make you guys aware, the fact that there's a wedge between the perceived cost of capital and the true does not imply irrationality. Okay, so let me give you a simple example under rational expectations. So imagine there's a firm, I, has some fundamental, I'll call it X, that follows an AR1, and the cost of capital is just some loading on X psi. Okay, the firm's perceived cost of capital is just psi times the persistence of the AR1 times X yesterday. The forecast error is just the negative of epsilon multiplied by psi. It's not zero, right? This firm is making forecast errors, but there's no irrationality here. Okay? So how do I know there's no irrationality? Well, I go to the GH regressions. The first regression is a regression of the true cost of capital on the perceived cost of capital, and you're going to get a coefficient of 1. Okay? The forecast error is uncorrelated with perceptions. There's no bias in the regression. The coefficient must be 1. Okay? The other regression that GH run is the regression of the forecast error on the perceived cost of capital. It turns out you can show that that coefficient is just 1 minus the first regression, and that coefficient should be 0, and indeed in this rational expectations model, it's 0. So these firms are making forecast errors, but these regression coefficients are 1 and 0. Okay? And it turns out this 1 and 0 is an extremely robust prediction of virtually any rational expectations model. So you can add complicated signaling structures, you can add a complicated filtering problem with transitory and permanent components. I kind of simulated that with a Kalman filter in my computer. I always got 0 and 1. I tried. Okay? So what's kind of the key insight of GH? Well, we can use this regression. In the paper, they focus on the second one, so I will too, which is the regression of the forecast error on perceptions. You can use that to measure the departures from irrationality. GH get a coefficient of like 0.9, whereas the rational model predicts 0. So these are just huge deviations from rationality. Okay? So let me give you an example of non-rational expectations that I kind of adopted by a recent paper by Yer and Ma, Ropelli, the Davids, Schreier, and Thesmar. Okay, so in this example, the true cost of capital is composed of like a firm fixed effect, R bar, and an AR1 component. But for some reason, the firm is loading too much on the firm fixed effect. It's kind of anchoring on the long run mean. It's loaded, the extra loading is captured by this gamma, and it's kind of underloading on the true process by a factor 1 minus gamma. Okay, so from there, I can actually derive the GH coefficient. It's kind of complicated, but it's linear in gamma. Okay, so if gamma is 0, we're back to rational expectations, this coefficient is 0. If gamma is not 0, this coefficient is not 0. It could be positive or negative depending on the relative variances of the fixed effect versus the AR1 component. Okay? So that kind of fits the mold of the GH analysis. Okay? We have a non-zero coefficient, we have non-rational expectations. Okay? But it turns out that that coefficient not 0 is not always evidence of irrationality. So let me give you another example. So this is my simple example from before, AR1 and a constant loading. Now imagine something slightly different. So the fundamental follows the AR1, but with probability pi, the loading is psi, like before. With probability 1 minus pi, the loading is larger. It's psi plus gamma. Okay? You can think about this like a version of a disaster risk model, where the second state is the disaster state. For some reason, the cost of capital is much more sensitive to economic conditions. Okay? We use that to explain asset pricing. Why not use that to think about cost of capital? It's not like totally crazy, I think. Okay? So in this model, the perceived cost of capital depends on psi, but it also depends on the probability you're going to enter the disaster state. The GH regressions in the normal state of the world give you a positive coefficient. The GH regressions in the disaster state would give you a negative coefficient. So you get departures from 0, but the model is completely rational. Okay? So what do I take away from this? Well, this coefficient not being 0, it might be a necessary condition to get irrationality, but it's not a sufficient condition. And I thought that was kind of interesting. Okay, it also made me think, can we ever rule out rational expectations, or can we always just make the data generating process more complicated? There's a large literature in macro thinking about anomalies and forecasts, papers by Koibian and Gorodnichenko. I couldn't fit their names on the slide, along with Michael Weber, who's probably somewhere here, Nakamura and Steinson. They have lots of theories to try and rationalize what looks like anomalies in forecasts, diagnostic beliefs, sticky information, and rational inattention, learning about parameters. And it might be nice for this paper to connect to that kind of broader literature. Okay, that literature also looks at more moments, serial correlation in forecast errors, the reaction of forecast error to news. And I think it'd be nice to have a more comprehensive sense of what these perceived cost of capital errors look like, what kind of belief formation processes can we rule in, what can we rule out, can we have a positive theory about how managers form beliefs. Okay, good. So in the last 2 slides, I want to revisit the quantitative part of the paper, which are the TFP losses. And to put this in context, for my calculations, GH calculated dispersion of a rational forecast of like 0.03. In my 2019 paper with Venki, we find that total MPK dispersion in CompuStat is about 0.45. That suggests that this irrational piece accounts for like 6% of total MPK dispersion in the data. Now, the TFP losses are linear in the MPK dispersion. So if GH calculate 5%, total MPK dispersion is costing 90% of TFP. Meaning if we could zero out MPK dispersion, we could almost double US productivity. GDP would go up by even more than that. That seems pretty large. So I thought kind of hard about what's going on in the paper, and I think there's 2 issues. Okay? So the first is that GH used this kind of work-hard-shame clean-out model with CES demand, Cobb-Douglas constant returns to scale production functions with coefficients alpha K and alpha L, and only capital is distorted. Now, in that model, the TFP loss is what I've highlighted in blue in the first line. It depends on sigma, the elasticity of substitution across firms, but it also depends on the relative share of capital and labor. And when I plug in some regular parameters, I get a multiplier of like 0.33 on sig2 MPK. That gives me TFP losses of just under 1%. Okay, what's happening in the paper is they're using the second multiplier, which is just sigma. They're getting a factor of 2, and that's why they're getting TFP losses of like over 5%. Okay, so I think the TFP losses should be like a factor of 6 smaller. Okay, and it turns out that their equation really only holds if there's no labor in the model. Okay, with labor, I know, I kind of understand what happened. She and Killian have this formula. You guys use the formula, but she and Killian have a correction that they publish later where they kind of correct the formula. And we also go through that in my paper with Venki. So I think you might want to look back at that formula. Okay. Good. So more generally, all is not lost. When capital and labor are both distorted, you get this kind of complicated formula that depends on the variance of the marginal product of capital, depends on the variance of the marginal product of labor, and it depends on the covariance of the marginal product of capital with the marginal product of labor. If the marginal product of capital and labor are perfectly correlated, then we get back to GH's formula. Okay, so what you kind of have to think about there is how do these mistakes in the cost of capital affect labor decisions? Okay, so if I were you guys, I would go to the data, calculate that correlation. It's plausible, and I wouldn't be that surprised if the correlation is positive, but I doubt it's 1. Just as an example, dispersion in the marginal product of labor tends to be much smaller than dispersion in the marginal product of capital. I know I've probably over time, just I have one more slide. Okay, so the second reason I think the TFP losses could be overstated in the paper is that the paper kind of abstracts from what we typically think about as something kind of boring, which is depreciation. All right, the cost of capital in any kind of standard investment model depends on the financial cost of capital and economic depreciation. Okay, so what I'm showing you is the optimality condition there, and your like simplest Q model, marginal product of capital equals the perceived financial cost of capital plus depreciation. When you approximate that equation, the log of the marginal product of capital, which is what matters for misallocation, has a scalar in front of the financial cost, which depends on the ratio of the financial cost to the sum of the financial cost plus depreciation. Okay? Then when you take the variance of the marginal product of capital, you have to square that scalar. And just to think about what that scalar is, in the paper they report like a mean cost of capital of like 0.1. If we think about depreciation as being around 10%, which is not crazy, that scalar is a factor of 1/4. Okay, so that again reduces the TFP losses by like a factor of 4. Okay? My last point here is, again, all is not lost. Let's think about a model where I extend that a little bit and think about firms with heterogeneous depreciation rates. So what am I thinking about here? Well, you know, a firm with warehouses or other structures as their main asset, their depreciation rates are going to be really low, like 3% per year. Whereas a firm in the high-tech sector, their depreciation rates are really high, like 25% per year. Okay? If we allow for heterogeneous depreciation rates, the log of the marginal product of capital is this kind of weighted average of the financial cost of capital plus the depreciation rate. The variance of the marginal product of capital depends on the variance of the financial cost of capital, the variance of the depreciation rate, and the covariance. And you can kind of restore the author's formula if you think there's perfect correlation between the irrational part of firm perceptions of the financial cost of capital and the depreciation rate. Now, I have no idea if that's true in the data or not, and that's something I haven't thought about at all. But kind of my overarching picture more generally is, you know, we might want to think hard about how these errors in the perceived cost of capital correlate with other firm-level observables. Distortions in labor, other inputs, depreciation, the true cost of capital, firm productivity, demand, et cetera, and how those correlations affect the misallocation cost of these mistakes. Okay? So I'll just wrap up there. I'll let you guys read the conclusion slide. This is a great paper, really, really interesting. The authors have done a kind of a nice service to the profession. They posted the data on this website. The paper's R&R QJE, so fingers crossed. I'm looking forward to reading the final version there. And thanks very much.
Thanks, Joachim.